Now, the question that is given here is for exercises 10 and 11. So this is the exercise 10 that is given here, and on the next page you have the exercise 11. Use the following diagram, okay? And then it is said that it is already given to me. What is the pieces of information that is given to me? AB is equal to AD. I can see that very well. This is the line AB, this is the line AD, they are equal. And then we have BC line, which is equal to the DC line, it is said. This is done. And then they are saying that I have to prove that the angle ABC, this is ABC, this angle, and I have to prove the angle ADC, this particular angle, are equal. Okay, so we'll start answering this part. Okay, now how do we answer that? Look at the 10th question in here. It states that which statement satisfies the step 3. So this is the step 3. Now what is the step 3? We have to give the reason why these two triangles are considered to be congruent. Okay, now I can see that I can very well see that the sides are given, the sides are equal, and they are also, the third side is also given. They have given that these are the two ones. Now AC is equal to AC. Now here I can say this AC belongs to this one and this AC belongs to this one here. So by SSS congruency, the three sides of the triangle are equal. So the triangle ADC, this is the triangle ADC, and is congruent to triangle ABC is what I learned, and that's what they are saying over here. The triangle ABC and ADC are congruent. And what is the reason? Okay, because they are congruent by the SSS congruency. Okay, and then what is the next answer that they are asking? What is the theorem that we are using here? SSS congruency that we are using for 10th question. Let's see what is the 11th question that is given to us. It states that which reason justifies the step 4. The congruent parts of the congruent triangles are congruent. This in short is the definition of the CPCT. What is CPCT? Now when I have two triangles which are congruent to each other, okay, the two triangles are congruent to each other, that means the triangle 1, everything in this triangle will be exactly same as the everything in the other triangle. They both will be exactly same. So in the previous question, in this question, we have seen the side and side are same. Hence we said that the triangles are congruent. Once after I have said the triangles are congruent, he asked me about this particular angle. So when the triangles are congruent, then by the congruent property, the CPCT, by CPCT, everything will be equal. Not just this particular angle, even this angle will be equal to this angle here, and this angle will be equal to this angle here. So this is what we understand. Now what does CPCT stands for? It stands for congruent parts of the congruent triangles are congruent. Okay, if the congruent parts are there of the congruent triangles, then they both, for 1 and 2 triangle, they'll be the same. Okay, this is the reasoning type of questions that has been asked. This type of question, the 12th question, is given to you in your examination revision worksheet, the quizzes worksheet. Okay, complete the following table. They have already given to me, they have clubbed two triangles together and they have given to me the pieces of information. What is given to me? Let's see here. It is said that EF and GH, there is EF, this is the side that is EF, and there is the side GH, this is the side, they are equal. Okay, fine. Apart from that, they are saying, he is saying that these two are parallel to each other. What is this meaning? This is read as parallel. Okay, they are considered as parallel. Parallel means they go in the same direction and they never meet. How much ever you extend, they will never meet. Why is that so? Because they are separated by a fixed distance. If this is 1 centimeter, everywhere I check the distance between them, they are separated by the same distance. This is what is called as parallel lines. So here it is saying that the EF line is parallel to the GH line. Okay, very well understood. Okay, Kabir, can I get the small pillow? Okay. And then they are asking us to prove the triangle EGH is congruent. I have to prove that the two triangles are congruent to each other. So how do I prove that? To prove that, these are the things that I have to give, have been given. Now, what is one piece of information that is given to me? There are two pieces of information given. If you see the given part, there is this one thing is given and this is the other thing given. So here they are asking me, what is the first given thing? So the first given thing that I have here is this EF is equal to GH. So I'll write EF is equal to GH side. Cool. Okay. Then they are asking the lines EF and GH. Okay, the lines that I have, they are already parallel to each other. Yes, this was also given to me in the equation here. So both the given pieces are done. And then we are saying that the angle FEH is congruent to GHE. FEH, this angle, okay, this is the angle, it is equal to GHE. So this angle, they both are equal. This angle and this angle are equal. How are they both equal? Because they form the alternate interior angles. What do they form? Alternate interior angles is what they form. Interior angles is what they are forming. Okay, now the fourth one, the reflexive property. What is the reflexive property? This is called as the reflection, right? Because this side is common to this, it is common to this. So the reflective property is seen with EH is equal to EH. EH for triangle 1 is equal to the EH of the triangle 2. Okay, fine. Definition of congruent segments. EF is congruent to GH. EF side is congruent to GH side. That is given. Then they are saying that these two triangles are same. How are they same? Let's name it. They are same by one side, one angle, and another side. So by SAS congruency, they are same. SAS postulate is what you say. Postulate or congruency rule is what you call it. Okay. Now, after mentioning that, they have given that there is another line QM which is equal to SD. The QM that I have here, it is equal to the SD line. Okay, this line and this line are same. Which one additional information is needed? Now in this two figures, and they have given that QT side is equal to the SV side. Now they want to apply which one additional information needed to apply the SAS congruency. So there's a side, in between the sides there's an angle that should be marked. So this is the side that I have. Okay, let me just mark it here. This is one side, this is the other side. This is one side and this is the other side. In between them there should be an angle because it is SAS congruency. And where do I see the angle? I see the angle here. So it is angle Q is equal to angle S is what I have to show. Then I can say that the two triangles are congruent by SAS postulate. What did I do? I showed that this particular angle that I have here is equal to this angle to apply the SAS rule, and hence when I do that, I get a very clear picture that the two triangles are congruent to each other. Okay, yes, two more pages and done. Now again in this particular question, they have given to me that complete the two column proof. Okay, the given pieces are AB side is equal to the CD side, it is congruent and equal, and then AB is parallel to DC. Okay, fine, this is the two pieces of information given. So the one piece of information, this has already been given over here. The second piece I have to write it down. What is the second piece? AB is parallel to the DC side. Because these are sides, I will write it with a bar. Okay, then they are saying that angle ABC is equal to DCB. ABC is equal to DCB. Why is that? So I don't know whether it is 90-degree angle or another measure of angle, but you see when you have two parallel lines and you draw a line like this, and when you draw a line like this, these are the parallel lines. Let me name the parallel lines. We are naming the parallel lines as L and M. Okay, in between the parallel lines, if any line goes and it looks like a Z, what does it look like? It looks like a Z. Okay, the angles that I get on the corners of the Z, those will be called as the alternate angles. What will be they called as? They would be called as alternate angles here. Okay, so also here it is forming a Z. Not necessary that the Z should be tilted or it should be this way. It can be any way possible. It can be like this also, it can be like this also, it can be like this, or any shape can be there. Okay, but just that there is this parallel line, there is this parallel line, in between that the line is standing or the line is like this. If it forms a Z kind of structure, then this angle and this angle will be same. Okay, now taking everything away, now the Z kind of structure that I have is other way around. Okay, this is the Z that I am having here. This is the Z that I am having here. So this angle and this angle will be called as the alternate interior angles. So we'll name it alternate interior angles is what I have. Kabir, what are you doing outside? And then BC is equal to BC. BC is the common side here and here. So it is the reflexive side. Okay, reflexive side, or the reflexive property is being shown here. Then SAS congruency. What is the SAS congruency? Clear everything away so that we better understand it. And we have the SAS congruency. This is the side, this angle you need to take. This is another side, and the angle between them is exactly same. So I would say triangle ABC is congruent to triangle DCB, or it is congruent to triangle BCD. They both are same is what I'm writing. Okay, then again the same kind of a question has been asked here, but this time they're talking about the QM and SD question. They have given QM is equal to SD, and they have given the QT is equal to SV, and then they are asking, if I have to supposedly apply the SSS congruency, how do I apply? Now this is one side, this is the other side. Now these two are done. Then I have to pick out the next third one here. How do I do that? This would be equal to this one here. So I will write what would be the condition. The line MT is equal to VD line is what I have. MT is equal to VD line is what we get. Okay, moving to the last question that we have here. Last set of questions for this particular topic. Complete the 2-column proof. What is the 2-column proof that we will see here? Now the proof is that V is the midpoint. Okay, the V is the midpoint they are saying, and the midpoint of WX and YZ. So that means midpoint divides the line WX, and YZ will be of exact same length. They will be of the exact same length. Okay, why? Because they are divided by a midpoint. So midpoint, it will be exactly in the middle. Where will the midpoint be? It will be exactly in the middle. Okay, so here this side, if I say this side is equal to this side, is what I get. Okay, fine. And I have to prove that. So the first thing that we will write is, after it they said that it is also a midpoint of YZ. So that means this side is divided by, and it is equal as this side. So the two pieces of information is given as, what I can infer from this is the WV, this part is equal to the VX part. This is one. The second is this side, which is YV, is equal to YZ. These are the two pieces of information given, and they have already written it here. YV and YZ, WV and VX are same. This is given to me. This piece of information is given. And what is it given? Given V is the midpoint. V is the midpoint. Okay, then it is saying the angles are equal. YVW. YVW. This angle is exactly same as ZVX or XVZ. Why is that so? Because they form the opposite angles. What do they form? They form the opposite angles. And we are using the SAS postulate. So SAS postulate shows that the triangle YVW is congruent to triangle XVZ. Okay, so that's what I'm going to write here. The triangle YVZ is congruent to triangle XVZ. No, XV, how much is it? Z. This is W. Here it is a W. YVW, and here XVZ is there here. Okay, so what is the piece of information given? It was given that V is the midpoint. I forgot to write the first one itself. It was given V is the midpoint of it. Okay, so these are the two pieces of information. This is the type of questions that will be asked, and this is how you write it down. Next is the below figure shows how the Greek mathematician Thales determined the distance leave this question. This question would not be, I hope they wouldn't ask this question, because it is with respect to the right angles, and the right angles part I don't think is given in the textbook, because they have given the last type of questions is this. Okay,